Well, this video is for my student who wants to know how to find domain of a rational function. So what I did was that I have taken only reciprocal function here. Rational function will have the denominator part as I've shown here and also some numerator part. But as far as the domain is concerned, domain is mainly defined by the denominator of the function, right? So most of the rational functions will have some polynomial in the numerator and a polynomial in the denominator. So domain of a rational function will be all the real numbers except for those which will make denominator as 0. Now instead of complicating the problem, I have taken simple reciprocal functions. Now reciprocal functions give me an advantage to explain this problem. The advantage here is that I can take an example like a square root in the denominator. If I call it a rational function, then I could not have taken this example on the page. So that's also an idea. I didn't want to confuse my student by writing rational here and taking a square root example here in the denominator. Remember, rational functions are ratios of two polynomials and square root is not a polynomial function. Okay? Now, that's why let's come back to this, and I hope you appreciate why I made this change. So it serves the purpose. It gives me an answer for domain of a rational function and also of functions which have something else in the denominator. May not be a polynomial. Correct? So that's how it is. And most of the time I think students get stuck when they have square root and things like that. Plus I will also like you to look into my video where we talk about reciprocal of a semicircle function, right? Semicircle is also having square root, correct? So that's also an important thing to look into. Anyway, here is the answer to this. So now, since I have taken the reciprocal function, it looks very simple. And domain is all real numbers. So we say domain is x belongs to real numbers for all these functions where x is not equal to something. And what that something is. What does this something do? This something is responsible for making denominator 0. So we say denominator, let me say denominator as d of x, something that makes denominator 0. So something which makes denominator 0. So that is the whole idea. So those are the restrictions. We cannot divide by 0, and that is why this restriction is there, right? So here what we will do is, we'll try to find what value of x makes the denominator 0. So that is the basic exercise which we are going to do here for each and every function. So the first one, so we'll call this as d of x, right? So let's find, so I'm writing d of x, which is our denominator, is equals to 2x plus 1. And let's find when is it 0. So we'll equate it to 0 and try to find the value of x, which will make it 0. So we say, well, 2x equals to minus 1 and x equals to minus 1 over 2. So here, so domain is all real numbers. And I'm not trying to repeat this all the time. What I will do here is this fill in the blanks I'm going to write here, okay? And what you can do is you can stop the video at this time, do it yourself, and then check your answer. That'll be very interesting. So here we have a restriction that x is not equal to minus half. So what I will do is I will complete this and say, well, for this function, domain is all real numbers except, or x is not equal to, I'll say x is not equal to minus half. So that is the domain of this function. Even otherwise, whenever you are given a reciprocal function or any function which has the denominator, it is a good practice to write the restrictions. So we call them restrictions also, right? Always write down their restrictions. That will help you in solving many problems. Okay, now second, again, we will equate the denominator to 0. So I'm not writing this time d of x. I'm assuming this d of x, right? So x squared minus 1 is equal to 0. So x squared is equals to 1 and x squared equals to square root of 1. And whenever we do square root, what should we do? We should do plus and minus here. So we know x is equal to plus and minus 1 because square root of 1 is plus and minus 1. So for this function, we will write, well, the restriction here is that x is not equal to plus and minus 1. Does it make sense to you? So domain for this function is all real numbers such that x is not equal to plus and minus 1. Do you get it? Okay, I think you are getting the concept, so I'll close this bracket for the time being. This can be filled up for all four of them. Now the next function, s of x. Now here we have more than not equal to 0. Since square root is not defined for negative things, this type of function has a restriction that 2x minus 6 should actually be greater than 0. Right? It cannot be 0 because it is in the denominator, and it cannot be negative because square root of negative number is not defined. Correct? So it has to be greater than 0. So we write here and solve this. So we'll take 6 on this side and divide by 2. That leads to x greater than 6 divided by 2 is 3. So that is what here it is. So here we will write our domain. So since it is different, I will use a different ink to write this. So here we will say x is greater than 3. So domain is all real numbers where x is greater than, not equal to 1 point, the whole region, right? So this domain is only defined where it is positive inside, right? So x greater than 3 will work, right? Let's say if I write x equals to 2, 2 times 2 is 4. 4 minus 6 is minus 2. And what is square root of minus 2? It is not a real number. It's imaginary number, right? So it does not fall into the domain of real numbers, right? So that is the restriction. And here I took a very special case. Now let's try to make this 0. That is to say x squared plus 1 equals to 0. That means x squared equals to negative 1. Well, you all know x squared cannot be negative 1 in the domain of real numbers, right? And therefore this function has no restriction. So this function has no restriction, right? So here x belongs to real numbers is our domain. So I hope you appreciate my point of not calling it a rational function and taking a square root function as one of the examples, because this is kind of unique where the domain is defined within a region, correct? This is also unique, and it reminds you that there can be reciprocal functions which have no restrictions at all, where the domain is set of all real numbers, correct? Try to graph this. I hope you remember and go through my videos. The graph of this will be kind of like this, okay? And always positive. Always positive, right? Remember seeing these kinds of graphs where there is no vertical asymptote. This is for such kind of functions, okay? And also look at the other videos where we are talking about range of reciprocal functions, right? That's the second half. How to find range of reciprocal functions? Well, there I will consider range of rational functions, okay? Thank you.